Welcome to your very first programming course. Okay, let's just be honest for a second. Jumping into coding for the very first time can feel a bit like staring at the Matrix, right? It's like you're trying to learn a super complex, intimidating foreign language totally from scratch. But what if I told you there's a blueprint you can write first using just plain everyday English? Well, in this explainer, we're going to demystify pseudocode. Think of this as your ultimate guide to decoding exactly how programmers map out their ideas before writing a single line of actual code.
So here's our agenda for today's explainer to jumpstart your algorithmic thinking. We'll briefly cover the programmer's essay outline, why we plan with pseudocode, a quick rectangle area example, visualizing with flowcharts, a positive or negative number example, and finally, some pro tips for readability.
All right, let's kick things off with Section 1, the programmer's essay outline, and writing your blueprint. Because jumping straight into a blank code editor is just flat out intimidating for a total beginner. But thankfully, there's a familiar stepping stone that makes the whole process so much easier.
Imagine you're staring at a blank document and you have massive writer's block. You wouldn't write a final term paper without jotting down an outline first, would you? Well, you really shouldn't write code without pseudocode either. Just like an essay outline maps out your thesis and key bullet points to organize your thoughts, pseudocode does the exact same thing for algorithms. It is essentially a rough draft using everyday language mixed with some really basic programming structure, things like start, get inputs, and if-then logic. It brilliantly bridges the gap between human thought and strict computer syntax, so you can focus purely on what the program actually needs to do.
Moving right along to Section 2, why plan with pseudocode, saving time, and preventing errors. So, why does this extra planning step actually matter in the fast-paced real world of software development?
Well, by mapping out your logic early, you are literally saving yourself from massive headaches down the road. For one, it prevents costly logic errors before the actual coding even begins. And if a program isn't working right later on, your pseudocode acts as a map to help you debug and find exactly where the logic went off the rails. Plus, because it's language independent, it acts as this universal roadmap. This is huge, you guys, because coding is a team sport. It allows developers to communicate their logic clearly to non-programmers, like project managers or stakeholders. These folks might not know how to code, but they absolutely need to understand how the application functions.
Okay, let's jump into Section 3, example area of a rectangle, show, don't tell. We're going to break down a super simple step-by-step example just to see how this actually looks in practice. Notice how we use clear, capitalized keywords to structure our logic here. We've got Step 1, start. Step 2, read length and width values. Step 3, calculate area equals length times width. Step 4, display area. And Step 5, end. We've organized the logic perfectly without worrying at all about the specific syntax or the semicolons or the brackets required by languages like Python or Java. Honestly, it reads almost exactly like a simple baking recipe.
But wait a minute, does this logic actually work? Well, let's test it out. Before we write any actual code, we need to do what's called a mental walkthrough or tracing to simulate exactly how a computer thinks.
Let's plug in some sample data. If we read the length as 5 and the width is 7, we move right along to the calculation step. We calculate area equals 5 times 7. Then the display output is 35. Boom! By manually tracking the inputs step by step just like this, we prove our logic is rock solid. And if the math was wrong, we'd catch the bug right here, right now, before ever typing a single line of real code.
Now, what if you're more of a visual learner? That brings us perfectly to Section 4, visualizing logic with flowcharts, the graphical alternative. While pseudocode is purely text-based, it actually has a visual cousin that represents the exact same logic.
That visual cousin is the flowchart. A flowchart is a visual representation of an algorithm, and it uses standardized symbols connected by arrows to show the flow of execution. So instead of lines of text, a flowchart uses specific shapes. You'll see ovals for the start and end of a program, rectangles for processes and calculations, and diamonds for making decisions. And all of these are connected by arrows to show the precise order of operations visually.
When we compare the two, it really illustrates when you'd want to use each tool. Pseudocode is text-based and incredibly compact, so it's absolutely great for detailing line-by-line logic without taking up a ton of space. Flowcharts, on the other hand, are visual diagrams. Sure, they require a bit more space, but they absolutely excel at visualizing complex decision branches. They make it super easy to track the flow of a program at a quick glance.
All right, let's level up a bit. Section 5, example, positive or negative, testing the waters.
let's see how our blueprint evolves when we introduce conditional decisions into our algorithm.
Let's trace this new logic out. Step 1, start. Step 2, read a number from the user. And now comes the critical decision in Step 3. If the number is greater than 0, then display positive. Step 4, else display negative. Finally, Step 5, and if and end. So here we're seeing if, then, and else logic written out in plain English. It's determining which path the program should take based entirely on the user's input. And hey, if you were drawing this as a flowchart, that if statement, that would be your diamond-shaped decision branching off into two completely different visual paths.
Okay, as we wrap up this explainer, let's check out Section 6, Tips for Readable Pseudocode, Pro Tips for Beginners. I want to leave you with 2 golden rules to ensure your pseudocode remains a helpful tool and doesn't just turn into a confusing, tangled mess.
First up, keep your statements language independent. Don't fall into the trap of using strict syntax or symbols that only apply to one specific programming language. Just keep it broad. Second, use problem domain vocabulary. And what does that actually mean? It means using plain language that describes the actual real-world task. For example, write append last name instead of using a robotic mathematical equation like name equals first plus last. Trust me, your future self and for sure your project manager will thank you for keeping the logic in everyday terms.
So, now that you've mastered the blueprint, what world-changing program are you going to build today? Remember, starting your first programming course doesn't mean you have to immediately memorize incredibly complex syntax. Pseudocode is that foundational stepping stone that makes writing real executable code an absolute breeze. Map it out, test it mentally, and just watch your logic come to life. Thanks so much for joining me, and enjoy your coding journey.